Hi ladies and gentlemen, in the last video you understood about a full adder. You understood its truth table, you did the design, then you implemented it in Qux and Verilog, you understood the wiring diagram. Now you have to understand the relation between a half adder and a full adder. So how a full adder can be realized using two half adders and an OR gate. So let me start with that presentation. Speech is organized into your learning outcomes, then a full adder with two half adders and what you learned. So what you will learn in this video is that you will learn to realize a full adder with two half adders and an OR gate. You will implement this setup in Qux and Verilog. Now this is a way you implement a full adder with two half adders. You cascade two half adders this way. First is a half adder. This is a half adder 1 and this half adder 2. This half adder 1 to which I supply this xn and yn. So the output of this is xn xor yn. So this is a sum output, this is a carry output. This I apply to another half adder with cn minus 1, so that this sum output is xn xor yn xor cn minus 1. xn xor yn xor cn minus 1. This is a sum output of a full adder. So if you take this as a block, you can see that the inputs are xn yn and cn minus 1, and the sum output is xn xor yn xor cn minus 1. This is how the sum part of a full adder is realized. Now if you look here, the carry of the first half adder, that is xn and yn, this line, this is xn and yn, and this carry output of the half adder 2, that will be, this input is xn xor yn and this is cn minus 1. So this output of this carry pin, what is coming out is cn minus 1 and xn xor yn. So these are ORed here. So what we get at the carry output, or the sum output of the OR gate, is xn and yn, or cn minus 1 and xn xor yn. So the sum bit of half adder is xn xor yn, sum bit of half adder 2 is xn xor yn xor cn minus 1. This is the sum bit of the full adder. Now half adder 1, this is cn minus 1 xn or yn. So what is the carry output? It is xn and yn, or xn and yn, or cn minus 1 and cn minus 1 and xn xor yn. So if I expand this, this xn yn or cn minus 1 to xn yn complement, or cn minus 1 and xn complement yn. So if I take this term as a common term, this xn as a common term, this becomes a yn or yn complement cn minus 1, or cn minus 1 and xn complement yn. This is yn or yn complement, it becomes yn or cn minus 1. Okay, xn and yn or cn minus 1, or cn minus 1 and xn complement yn. Now if I expand this, it becomes xn yn or xn cn minus 1, or cn minus 1 and xn complement yn. So this is xn yn or cn minus 1. If I take it out, it becomes xn or xn complement yn. So this becomes xn yn or cn minus 1 into xn or xn complement yn is xn or yn. So that this becomes xn yn or xn cn minus 1 or yn cn minus 1. This is the carry output of a full adder. We earlier saw this carry output of a full adder. So this setup actually realizes a full adder. This is the way I realize a full adder with two half adders and an OR gate. This can be simulated in Qux. I will show you that. Now each of this is a half adder block. This is a half adder block, this is a half adder block, and these are interconnected this way. Now here the even odd pins are here. I will go into the circuit. This half adder circuit looks like this. I will go into this sub circuit. We can see that this is a sub circuit. Here you can see that this P2 and P1, P4 and P3 are the output ports, and P1 and P2 they are the input ports. So if I go here, P1 and P2 I give two signals, that is Xn and Yn. Okay, this Xn and Yn I give to the first full half adder. So the outputs are 4. 4 is my 4 is coming here, and 3 is given to the second. This is a sum output. This is given to the next half adder. So to which the Cn is also given. Cn minus 1 is also given here. So this is the first half adder. This is the second half adder. Now this carry thing, this carry is ordered with this carry. So this gives my C out. So if I run this simulation, we can know how this behaves. We can run this simulation. I will remove this thing and these two sources because I don't need them. Now you can see that it behaves like a full adder. Now 0 0 0 it is 0 0, 0 0 1 1 0, 0 1 0 1 0, 0 1 1 0 1, sum is 0 and carry is 1, 1 0 0 it is 1 0, sum is 1, carry is 0, 1 0 1 sum is 0, carry is 1, 1 1 0 sum is 0, carry is 0, 1 1 1 sum is 1 and carry is 1. Now this is now you see that it is a truth table of a full adder. Now how do I realize that? With two half adders and an OR gate. Okay, this is the first half adder, this is the second half adder. This output is connected to the input of the second half adder. Some output of the first half adder is connected to the sum input of the X input of the second half adder. The carries, the carry here, the fourth pin, that is a carry of the first half adder, that is and the carry of the second half adder, they are connected to and an OR gate. Okay, this is an OR gate to form your final output carry. This is the outputs. This is the sum output. This is how I realize a full adder with two half adders. Now let me go back to my presentation. Now I can simulate this setup in Verilog also. What I need is I have to include a half adder block. So earlier I have made a half adder. So I include that half adder. Grave include half adder H adder dot B. This includes my half adder block. Okay. Now I realize a half adder, some module called half adder, full adder with half adder, full adder with half adder, module full adder with half adder, end module. Here the output wire is some count because it's nothing but a full adder, so it is output wire some C out and input wire X, Y and C in. Now the intermediate the internal nets are the wire A, B, C. Now I have to have two half adders. I have to instantiate two half adders. One is H adder HA1. I have to give this name, some name HA1, H adder HA1 A, B, X, Y, because to which X and Y are given as inputs. The sum is A and the carry output is B. Now another half adder is instantiated HA2, to which I give one of the inputs is sum from the previous stage, that is A, and the other is C in my carry input. Okay, and I get this is the carry output of the second half adder. So carry outputs are sum is generated and the carry outputs are A and or B. A should be ORed with B to get my carry output. So OR C out is my C out, my carry out. This is nothing but OR C out B comma C and end module. Now I have to run this code. I will show you how to run this code. This is my uh, half full adder with half adder dot v, and here is a test bench for that. Now this is my full adder with half adder. I include the H adder, then two instantiations of half adder. Two half adders are there. Then the carry output is obtained by ORing the carry output of the two half adder stages. Sum is created by cascading. Now I open a terminal here. I will enhance this. I will zoom this a little. I type Verilog. .v. Now it runs without any problem. Now I say tb, the test bench, and if you look at the test bench, it is pretty straightforward. Here this is my test bench. Here I include my full adder with a half adder dot b. Then the remaining thing is the same as that of the full adder, except the name of the VCD file. Here I put a different name, full adder with a half adder dot VCD. Everything else remains the same. Now when I run this code, this I say some minus o a dot out. So if I run this a dot out, you can see that it realizes a full adder. Now here you can see that x and y carry in, they are 0, the output is 0, the sum is 0, the carry out is 0. This 0 0 1, sum is 1 and carry out is 0. Here 1 0 1 0, sum is 1 and carry out is 0. This is 0 1 1, sum is 0 and carry out is 1. This is 1 0 0, again carry sum is 1, carry out is 0. 1 0 1, sum is 0, carry out is 1. 1 1 0, sum is 0, carry out is 0. 1 1 1, sum is 1 and carry out is 0, 1. Okay. You can appreciate the waveforms also, like a GTK wave. .vcd. So x is appended, y is appended, carry in is appended, sum is appended, carry out is appended. Now you can zoom this a little. Now you can see that for up to 5 seconds it's an indeterminate state, then it is a 0 0 0 0 0 1 that way. So here it is 0 0 1, the sum is 1, carry is 0. 0 1 0, sum is 1, carry is 0. This 0 1 1, sum is 0 and carry is 1. Then 1 0 0, sum is 1, carry is 0. 1 0 1, sum is 0, carry is 1. Then 1 1 0, sum is 0, carry is 1. This is 1 1 1, that is sum is 1 and carry is 1. So that is how I make a full adder with two half adders and an OR gate. Now what you learned in this video is that you learned to realize a full adder with two half adders and an OR gate. Then you implemented this setup in Qux and Verilog, and that is the end of this video. I thank you all.